Hello, Professor Tree. We are Group 12 from CCO1 class. Today we're going to talk about our topic, soil moisture sensor. About the contents, there are problem statements and development timeline, introduction and overview, engineering design process, technical implementation, and the final part is result and conclusion. Development timeline we separate into four phases. Phase 1 research and definition. We identify problem and research background, define technical requirements and specification. Phase 2 design and prototyping. We start to brainstorm idea and select best solution like ASP32 and capacitive. Then we design schematic, PCB and build the hardware prototype. Phase 3 testing and optimization. We test and evaluate sensor stability accuracy. Then we improve design. Phase 4 completion. We finalize documentation and project presentation. Design conference. With the budget, we got a low cost implementation for scalability. Environment must resist corrosion in wet soil. Technology needs to be required auto for multitasking and Wi-Fi for real-time monitoring. A problem statement, we have the importance of soil moisture. Water conservation prevents water waste caused by overwatering, promoting sustainable agriculture. Plant health avoid root rot and drought threat. The final is yield optimization. It maintaining consistent moisture level ensure faster growth and higher crop quality. And also we got another one, limitation of current methods. Manual inspection, traditional methods like finger tests are subjective, inaccurate and labor intensive. Also, it lack of real-time data, because without automated monitoring, user cannot react promptly to environmental change.
Welcome Mr. Tree and everyone. My name is Hoàng Minh Khoa and I'm in charge of the hardware implementation for the soil moisture sensor project. As Thắng has introduced about the importance of soil moisture to the health of plants, too much water will make the roots rot, not enough water will make the plant wither. So there is a need for an automated way to measure the content in soil. We will introduce you to the soil moisture sensor. A soil moisture sensor is basically the device that measures the humidity of the soil. It acts as a wetness detector for automated gardening and irrigation systems. This is the backbone, the fundamental of highly automated agricultural systems that you usually see in Israel and other developed countries. At first, when we came to Nhật Tảo market to do research for the tools that we are going to use in this project, we first came up with the resistive soil moisture sensor. It works by letting a small current flow through the electrodes. When the soil becomes more humid, the resistance in the soil will become small and the current will gradually increase. There's a small circuit with a resistor there for you to calibrate the sensitivity of the module. This module is really cheap. We bought it for just around 15,000 at Nhật Tảo market. It is easy to use, but one big disadvantage is that it exposes to electrodes which is prone to corrosion. And secondly, it is affected by soil salinity, which means after you fertilize your crop, the moisture received from the sensor could be affected, so we will have to calibrate it frequently. This is not ideal for a long-term project and not stable enough. so we decided to replace it with a capacitive moisture sensor. It is much more durable, stable, and consistent. It measures moisture based on changes in soil dielectric permittivity, which is the capacitance measured in soil. It has no exposed metal parts, so there is nothing to be corroded. It is much more durable, and the only disadvantage of it is the price is slightly higher than the resistive moisture sensor. You can see on the animation here, as the soil becomes more humid, the capacitance in the soil increases, which leads to a lower signal voltage output. And the second part, for the microcontroller, our project will implement the system using an ESP32 microcontroller. It is a higher speed processing power than an Arduino board. And secondly, it has a dual core 32-bit processor. The reason why we didn't choose the Arduino for this project is that it does not come with the Wi-Fi module, and we think that an IoT project without internet really loses the beauty of IoT. So we'll go with the ESP32 for the total diagram architecture of the system. We have a LiPo battery, a small LiPo battery to power the whole system. It is connected to an ESP32 controller through an ADC pin. The soil moisture from the environment will be measured through the capacitive sensor, and when connecting to the ESP32, we will debounce the signal by using a small low-pass RC filter around 100 nanofarad. This is necessary to smoothen the waves into the ESP controller to make it more smooth and less noisy. This is the system architecture of our overall project. This is the components that we have bought, including a LiPo battery and the ESP32 microcontroller. This is a smaller version compared to the one that you have seen in the previous slide, and the capacitive soil moisture sensor. We 3D printed a plastic cave to put the whole circuit in to avoid, make it less prone to resistance, less prone to corrosion, so water cannot affect them. The estimated price for the whole component is around 250,000 Vietnam dong. And next will be the presentation of Nguyễn Hiếu Trung.
Hello everyone, I'm Jun. Today we'll present you about the software for the source motor sensor. The first section is the platform. In terms of platform, we choose Platform.io for many purpose. So what is Platform.io? Platform.io is a powerful open source ecosystem design for cross-software development of IoT and embedded system application. It's built on the Python language and functions as flexible multi-platform IDE that run on the variety of OS. So, why do we use Platform.io? Here is some advanced feature for proving that. Multi-architecture, which means it supports a huge number of MCU. The second one is the PS4 Interact. Platform.io is most commonly used as an extension. The next one is Library Manager, which robust library management. that help us easily search, install, and update library across different platforms. The finally is the professional building system. The next section is the structure applied in the system. Because of taking a signal consecutively, we decide to follow the RTOS structure. So what is the RTOS structure? RTOS stands for Real-Time Operating System, which is the operating system designed to solve applications that require extremely high timelessness and predictability. In an embedded system, the microcontroller needs to perform many things simultaneously: reading sensor, handling Wi-Fi communication, updating a display, and responding to button pressing. Without an RTOS, we would have to write a complex subloop filled with delay and if-else function. So with an RTOS, it allows us to split the application into independent tasks. The RTOS uses a structure to manage the CPU switching between these tasks based on their priority, and so the most critical task is always handled in time. Secondly, predictability and determinism are the single most critical reason in real-time application. Responding to the event within milliseconds is not a wish, it's a requirement. An RTOS will provide mechanisms like semaphore vertex to manage resource sharing and inter-task communication safely and orderly, ensure that the context switch time is short and predictable, allowing the system to consistently meet stringent timing deadlines. Finally, for easily maintaining and updating the system in the future, we should divide the code into independent tasks. It's easy to leave a task from one project and use it in another, and the bug in the one task is likely to rush the entire system. As the right-hand side, I split the system into three different functions that are task LCD, task network, and task reading, which we'll check after doing all steps before. Then we need a website to publish the signal from the sensor for controlling real-time system. Therefore, we decide to use Core IoT server to do that job. So what does Core IoT do? The web server will link with ISP32 by the address token and take the signal of the sensor that is provided by ISP32. So why do we choose a Core IoT as a web server? Firstly, it allows us to visualize the signal graphically, with it to easy handling and controlling of the system. Second, access one step by using a token and updating after 5 seconds. Here is some note of security. With Because of easily access, this may cause a lack of data when the attacker hack it. Therefore, in the future, we will apply the SSA 256 report to the system to ensure that the data from the sensor to the server is integrity.
And the final part is conclusion and what have we learned? Project achievements. System stability successfully built a soil moisture monitoring system using SP32 and auto with high stability. accuracy and durability, solve the corrosion issue by using capacitive sensor and reduce noise with hardware-software filters. Connectivity, real-time data visualization on core IoT web server with low latency. In real-world application, we have smart gardening, which automated monitoring for home plants. Precision agriculture help farmers optimize irrigation, saving water and improving crop yield. Research and education, a low-code open-source model for IoT learning. And in future, we also want to make some improvement like security upgrade, implement SHA-256 encryption to secure the auth token and prevent data leaks. Power optimization, integrate deep sleep mode and solar charging to extend battery life for remote deployment. Hardware, design a custom PCB for a more compact and professional look. And thank you for your attention. We also want to say thank you to Mr. Nguyễn Cao Trí for your guidance and support throughout this project. We deeply appreciate the valuable soft skill and advice you share, which will be a great access for our future. Thank you so much.